In the heart of America's farmland, the rumble of engines across the soil is no longer just the sound of steel meeting earth, it's the sound of intelligence, precision, and data all working in harmony to coax record-breaking yields from every acre. The modern American farmer doesn't just drive a tractor, they command a machine packed with more technology than the first spacecraft. As the sun rises over vast fields of corn, soybeans, and wheat, a revolution unfolds, one that merges traditional farming grit with artificial intelligence, satellite data, and cloud computing. High-tech tractors are reshaping the landscape of agriculture in the U.S., and the transformation is profound. Equipped with GPS systems accurate down to a single inch, these machines navigate massive crop fields autonomously, tilling, planting, fertilizing, and harvesting with a level of precision no human hand could match. Farmers now sit in air-conditioned, touchscreen-equipped cabins, or in some cases, monitor operations from tablets and smartphones miles away. They are more than farmers, they are data analysts, drone pilots, and agri-tech engineers in their own right. The key to high yield isn't just about planting more seeds, it's about planting smarter. Modern tractors, linked to central computer systems, evaluate data from previous seasons to determine the most productive parts of a field. They then adjust seeding rates accordingly. For example, in areas where soil fertility is high and drainage is optimal, the tractors will plant seeds closer together to maximize potential. In rockier or more flood-prone zones, they'll space them out to reduce waste. These real-time decisions are powered by sensors that analyze soil composition, moisture levels, and topography, often while the tractor is in motion. For crops like corn, which dominate the Midwest, the impact is immense. A farmer in Iowa can input a corn hybrid's ideal planting depth, spacing, and fertilization schedule into the tractor's control panel. The machine then automatically adjusts its implements, depth wheels, seed discs, and fertilizer applicators, as it moves. Each seed goes into the ground at exactly the right depth, with just the right amount of nutrients, and within inches of the next, ensuring even growth and maximum sun exposure. Soybean farmers use similar technology to improve efficiency. Because soybeans require a delicate balance of soil nitrogen and water, high-tech tractors are often synced with variable rate technology, VRT, applicators. These devices modulate the amount of fertilizer or pesticide based on real-time field conditions. For instance, if satellite imagery detects a fungal outbreak in one corner of the field, the system will automatically instruct the sprayer to target that area while skipping unaffected zones, reducing chemical use and environmental impact. Wheat, the backbone of bread and pasta, also benefits immensely from this technological leap. In Kansas and North Dakota, precision planting and harvesting machines use weather modeling to schedule sowing times that align perfectly with optimal temperature and precipitation forecasts. Autonomous combines then harvest the wheat with minimal waste, guided by AI-powered cameras that distinguish ripe heads from underdeveloped ones. These machines even adjust their blade height on the fly, ensuring every valuable grain is collected. But tractors are just the beginning. They are now part of an intricate ecosystem that includes unmanned aerial vehicles, drones, field sensors, cloud-based analytics platforms, and mobile apps. Tractors often act as the central node, relaying information from these sources to farmers in real time. For instance, a drone might fly over a field of cotton in Texas and identify a section where pest activity is unusually high. That data is transmitted to the tractor's onboard system, which adjusts its pesticide application route accordingly, saving time and resources while protecting the crop. The integration of machine learning and AI is taking precision farming even further. John Deere, Case IH, and other leading tractor manufacturers have developed systems that learn from every pass across the field. These tractors analyze yield maps, machine efficiency logs, and environmental conditions to continuously improve their operations. Over time, they begin to make recommendations: when to plant, how to rotate crops, or even when to delay tilling due to predicted rainfall. It's a silent advisor that rides along every acre, whispering data-driven wisdom into the ears of the grower. Even irrigation, a lifeline for crops like lettuce, alfalfa, and tomatoes in drier states like California and Arizona, is being optimized by smart tractors. Many of these machines are equipped with real-time evapotranspiration sensors and can adjust irrigation based on crop stress levels. Instead of saturating entire fields, they now deliver water only where it's needed, inch by inch. It's the difference between brute force and surgical precision, and it's revolutionizing water conservation in agriculture. Of course, yield isn't only about growing more, it's also about reducing loss. Tractors are now helping farmers prevent post-harvest waste through advanced threshing systems that separate usable grain from chaff more effectively than ever. Moisture sensors ensure crops are harvested only when they're dry enough for storage, preventing spoilage. When paired with automated grain carts, these systems eliminate bottlenecks during harvest, allowing farmers to gather their crop at peak ripeness without delay. A single tractor pass can now collect gigabytes of data: soil health, planting depth, tire pressure, engine performance, GPS tracking. That data gets uploaded to cloud platforms where farmers can view detailed dashboards that resemble those used by financial traders. These dashboards show which parts of a field are underperforming, which seeds performed best under stress, and how different management strategies affect overall yield. This turns every planting season into a feedback loop, where farmers refine their strategy with each cycle. The scale is astonishing. A single high-tech tractor can plant hundreds of acres per day, with an error margin of less than an inch. In states like Nebraska, where corn is king, it's not uncommon for a farm to harvest tens of thousands of bushels in a matter of days, thanks in large part to this machinery. These efficiencies help offset the rising cost of land, labor shortages, and unpredictable weather patterns brought on by climate change. The financial return is undeniable. Though a top-tier autonomous tractor can cost several $100,000, the investment pays off quickly. Higher yields, reduced input costs, lower labor requirements, and longer equipment lifespans all contribute to the bottom line. More importantly, these machines give farmers peace of mind, knowing their crops are being nurtured with surgical precision, 24/7. Even the fuel systems are evolving. Many of today's tractors run on biodiesel or hybrid engines, further reducing their carbon footprint. Some manufacturers are experimenting with electric drivetrains powered by solar charging systems, and soon we may see entire fleets of zero-emission tractors tending fields with little more than sunshine and software. There is also a profound human element to this high-tech transformation. For generations, farming was a manual, often grueling labor that demanded early mornings, aching backs, and weather-hardened skin. While that spirit remains, today's farmer is just as likely to be found analyzing spreadsheets and coding drone flight paths as they are fixing a broken axle or walking rows of corn. The technology hasn't replaced the farmer, it's elevated them, giving them tools to grow more food for more people, with greater sustainability and precision than ever before. And the crops themselves are better off for it. Corn ears grow more uniformly. Soybeans flower more predictably. Wheat heads are heavier and more abundant. The overall health of the plants improves because they're receiving just what they need, no more and no less, thanks to the unblinking accuracy of their robotic partners in the field. In every furrow and field, from the amber plains of Kansas to the lush valleys of California, technology and agriculture are writing a new story, one in which tractors don't just work the land, they understand it. The result is a farming system that's smarter, faster, and more resilient. These aren't just machines, they're the nerve centers of modern agriculture, helping American farmers feed a growing world with unprecedented efficiency and care. And as this quiet revolution rolls on, one thing is clear: the future of farming is already here, humming steadily across rows of sunlit crops, driven not just by diesel and steel, but by data, vision, and a relentless pursuit of growth.